Alright guys, today's goal, the learner will understand how to graph square root and cube root functions. Alright, so I look at this. It says, graph the function, then state the domain and range. Alright. -3 doesn't mean anything because it's outside the square root. Underneath the square root is x. Well, I know that square roots have to be greater than or equal to 0. So I know x has to be greater than or equal to 0. So for the domain piece, how do I write that? I'll put it down here. It can equal 0, and it goes to infinity. Okay, so now, so what do we do? Well, I would pick, to graph it, I'd pick the first 3 perfect squares. So I'd do 0, 1, 4. So mark up the graph. You plug in 0. You get 0. Plug in 1. -3. Plug in 4. -6. So I get 0. And then I get 1, -3. 2, 3, 4, -6. So what is this range doing? What are the y values doing? They're starting at 0. Their max is 0, and then it goes down forever. So you would do -infinity to 0. Okay? So with these brackets and parentheses, think about this. On a number line, remember that meant does not equal, and filling it in dark meant does equal. Okay? So let's take a look at another example. Graph the function, then state its domain and range. It's cube root. Well, you can take the cube root of positives and negatives. So I already know domain is -infinity to positive infinity because it's all real numbers. Okay? Now I would start with the first 3 perfect cubes. 0, 1, 8. So you mark it off. I put 8 out there because I had to have at least 8. So if I plugged in 0, -1/2 cube root of 0 equals 0. -1/2 cube root of 1 equals -1/2. So I have 0, -1/2, and then -1/2 cube root of 8 equals -1. So you might want to also then try the -1 because we need to get positive and negative sides of it. So if I did -1, be +1/2. So that'd be here. And then I have 0, 0. And then I have 1, -1/2. And then I have 8. -1. So guess what I would get if I had -8, +1. And you can always check on your graphing calculator to make sure you're getting the good shape of it. But see how I plotted all those points and graphed it. Okay? Now the range. It looks like it's getting flat, but if you plugged in like 1,000,000 and did it, you'd get -1,000,000. If you plugged in -1,000,000, you'd get positive, the cube root. And so the range is also negative infinity to positive infinity. Here's the nice thing. For cubics, the domain of range, always that. Doesn't matter what it is, it's always that. Okay? So take a minute, press pause, please, and then try to state the domain and set up the table that you think you should graph. All right. Well, hopefully you press pause because you need to try on your own. So, domain. Should have been 0 to infinity. Meaning, this means, remember, we got to learn what these mean. This means x is greater than 0. So all real numbers greater than or equal to 0. Not greater than, but greater than or equal to. So when it's square root, 0, 1, 4. So if I plugged in 0, I'd get 0. If I plugged in 1, I'd get 1/4. If I plugged in 4, I'd get 1/2. So I get 0, 0. Since they're so close to the 0. Since they're so close here, I do 0, 0, 1, 1/4, 4, 1/2. So this is going to be a very small increasing line. So the range starts at 0, goes to infinity. So here's the thing. If you remember, the range here, A was positive, that means it's going to end up at positive infinity. At the first example, A was negative, and see how it ended up at negative infinity? Okay. All right. The period of a pendulum is the time the pendulum takes to complete one back and forth swing. The period T in seconds can be modeled by T equals 1.1 times the square root of L, where L is the pendulum length in feet. How long is the pendulum if it has a period of 1 second? So you get 1 equals T. No, that's what the T equaled. 1 equals 1.11 times the square root of L. Well, divide both sides by 1.11. Square root of L equals 1 divided by 1.11. Well, I would just leave it like that. And then how do I solve it? Square both sides. So the length equals. So in your calculator, to get the best final answer, you should put in there, in parentheses, 1 divided by 1.11 to the second power. So the length would be 0.81 feet. Okay? So there we go. All right, translations of radical functions. This should be familiar, seeing these things. The procedure for graphing functions of the form y equals a times x minus h plus k. Y equals a cube root of x minus h plus k is described as below. Okay? So, it says the graph of y equals a times the square root of the quantity x minus h plus k or y equals a times the cube root of the quantity x minus h plus k. Follow these steps. Sketch the graph of y equals a times the square root of x, and a times the cube root of x. And then translate the graph horizontally and vertically. So the h and the k mean the same thing as what we learned, and if a was negative, it's reflected over the x-axis. Okay? So what they're saying to do is graph this first. So we've learned how to do that. 0, 1, 2. So let me move this up a little. I'm not sure with the movements what I'm going to need, so I'm going to put 10 on there. Hopefully that'll be enough. Alright. So if I plugged in 0, I'd get 0, 1, 1 half. I'm going to use 4. 4, I'd get 1. So if we graph this, 0, 0, 1, 1 half, and then 4, 1, we get this. Now what they're saying to do, what does the 3 mean? This means 3 right, down 1. So start at 0, 0 and move 1, 2, 3 to the right, down 1. Start at the 1 half and move 1, 2, 3 to the right, down 1. Start at 4 and move 1, 2, 3 to the right, and down 1. Now, then state the domain and range of this. Okay, so here's the thing. Instead of starting at 0, 0, this one started at 3, and it was at negative 1. And then it went 4, because see how I went add 3, add 3, add 3 to all these? And you get 7, and then what did we do? Minus 1, minus 1, minus 1. So you get negative 1 half, 0. So the domain of this one, where did it start? 3. And it was going up, so infinity. The range, where did it start? Negative 1, and it's going up, so infinity. So you got to graph both. Okay? So let's try this one. Now remember what I said. Domain and range we already know. Negative to positive infinity. Let's see if we're right. So this one you're just going to be graphing g of x equals negative cube root of x. So I'm going to do this. Just so we get a better distance, I'm going to do negative 8, 0, and 8. I'm going to give some room here to apply the transformations, though. So negative 8, that's x, that's y. So negative 8, 0, and 8. So the negative cube root of negative 8 would be 2, and then 0, and then negative 2. Alright, so let's graph these ones. So negative 8, positive 2, 0, 0, and positive 8, negative 2. So I get this. Now it says left 2, down 3. So this means minus 3, minus 3, minus 3. And this means negative 2 plus, negative 2 plus, negative 2 plus. So left 2, down 3. Left 2, down 3. Left 2, down 3. Okay? But the domain is still negative infinity to positive infinity. Well, hopefully you're seeing these shifts, the vertical and horizontal shifts, and the reflections. So I will see you guys in class tomorrow.